All right, so you have your written test this Wednesday, right? So the time for starting the test is a little bit different from the programming test, so please do check the guide, right? It started a little bit later than usual, but do check. You don't want to miss any time from there. Your written test 1 and okay, so programming test 0 and 1. I just released the marks and feedback yesterday. If you got any concern, you can feel free to submit a regrading request. But if you're hesitant about whether you should do it or not, I'm more than happy to talk during the office hour. Or if you can catch me briefly after class, or maybe tomorrow, if you see me being available, you can also approach me. Sorry, not tomorrow, I mean Wednesday during the test. We can talk too. All right, so all the resources are available to you. Oh, for Saturday, the review session didn't run for long, just for 30 minutes, pretty sweet, and I think some useful stuff. I will also make the recording available. I just didn't have time to do it over the weekend. I'll do that. So you can also refer to it if that can help. And your lab number 3, of course, so please make sure you also make some steady progress on your lab 3 as well, okay? So this week, I'm hoping at least to finish the equals method. Takes a little bit, more slowly than I thought, but I think we just want to have thorough discussion. I think that's more important. And then we'll definitely move on to inheritance as soon as we are done with the equals method. All right. No worries. All right, guys, any questions about how the course is going to progress? 5 more weeks, okay? All right, let's now do a recap from last time, very quickly, and then we'll move on. All right, so last week we spoke about this very, very important page. I think we're going to apply this principle again today, which is to say, whenever you got any equals method call, which version of the equal should we call? Is it going to be the default version from the object class, or is it going to be the overridden version from a particular class, like a point v2, for example? How do we determine? You only look at the context object over here. You can disregard the arguments when you make a decision for that, right? Once you figure out the context object here, x, at the point of executing this particular method call, x must be pointing to some objects, and look at exactly what this object is in the title, the dynamic type. I'll show you a little bit more. Usually you determine the dynamic type by looking at the name of the constructor you call when you create that particular object. I'll show you more examples just to brush up your mind. So once you determine dynamic type and go to that particular class and see if the equals method is explicitly overridden in there. If it is, call that version. If it is not, call the default version, right? So it's very important for you to make that distinction very clearly. Any questions about this principle here? So important, all right? And then we spoke about the default version. So in this case, you can look at all the context object here, P1, 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 and P2, right? So all of these were created using the constructor from point V1. So you look at the name of the constructor to determine what's the dynamic type. And we'll speak about later today about another kind of type called static type. I'll make that distinction a little bit later. But for now, dynamic type only look at the constructor. So that means all of them are going to call point V1 version of the equals method. When you look at the point V1 class, no overridden version of equals. So that means we're going to call the default version, right? So all the tracing goes after that. And then we spoke about one particular case where you're trying to say equals between P1, which is point V1, and also S, which is a string, right? When you actually passing S as an argument being a string, that's okay. Because as far as the argument is concerned for equals, as long as it's an object, you're okay. By definition, everything is an object in Java, so that's okay. However, if you try to compare P1 and S directly using the equals, it's not even going to compile, right? We kind of explained that also last time. Okay, notice that subtlety here, which is also important. And then we talk about call by value, so which we're going to talk about the equals overridden version today, line by line. Okay, we're going to speak about it exactly every phase. You just got to remember when we try to trace the code for different phases for the overridden version, the OBJ over here is really a copy of the address of the argument. For example, let's do this one quickly. If I do this method call, p2.equals p3, it's a method call, so we got call by value. According to call by value, the value of the argument, which is p3, like address, That one there is going to be copied to initialize the parameter obj. So that means visually, obj and P3, the argument, they point to the same objects. So this is the starting point for executing the equals method, the overridden version. Okay, just bear in mind, right? So we are really just trying to apply what we learned from the call by value over here. Any questions about applying call by value? Go ahead.
Just a question about dot equals. When we do like P2 dot equals P3, does it compare the address or the attribute value?
Okay, so when you talk about, let's say this one here, very quickly, you're basically talking about which version is going to call, right? Let's revisit that principle. If I look at this line here, P2 dot equals P3, to really know which version to call, I don't have to worry about arguments. I only worry about context objects, right? So look at the context object here, which is P2. P2, at this point of execution, it is pointing to this object here, and it's by point V2, right? Point V2 actually comes from the constructor name. So we know that it's going to call the point V2 version. And point V2 indeed has an overridden version that's going to call, and we'll talk about exactly how it's going to work, right? So decision making is really just the same. We're just going to keep repeating until it's really natural to you about how to determine. All right, and then I think, and then we took a break last time, and then we spoke about short circuit evaluation, right? So guys, please make sure you go over the practice question about short circuit evaluation. It's going to be covered on Wednesday, all right? That's a big hint. Well, not big hints, some hints for you. So we just spoke about the truth table, and also for the n%, and also for vertical bar. So please review the truth table and also understand about the short circuit evaluation. Always remember, evaluation is going to be from left to right, always. In the case of n, you will only go on to operand number 2 if operand number 1 is true. All right, so we also talk about the correspondence in the rows in the truth table. For that one, you can revisit the recording to see. On the other hand, if you think about short circuit evaluation for the OR operator, you will only move on to the right-hand side if the left-hand side is false. All right, it's a kind of symmetric between the two operators. You don't really have to memorize them, just make sure the logical reasoning is actually clear to you, okay? So you'll be better for you to really even kind of keep it even beyond this course. All right, and then we did some examples. So this will be a typical usage for protecting array indexing. You want to make sure the value of I, the index, is not too small, also not too big. So that's why these two guarding conditions must be put before that, right? And then you should also try it out. What if I try the OR operator? Okay, one more thing to mention right here. So we say that whenever you got an operator, this condition here is called a guarding condition, meaning that if the guard is passed, you can go on to the next one. And this one here, the OR operator, we say that the condition here is like a logical negation of what you will put for the AND operator. It's called an error condition. What does that mean? If the error condition is true, you should really avoid evaluating the second one. So think about these names. They're really there for a reason. Okay. All right, any questions? All good? All right. Okay, let's now move on to for today. Okay, so let's now dive directly into the overridden version of the equals method. Right. So just very quickly, so just to let you know, so this will be a very typical way. Well, it's very standard way of defining the equals method. You will see that we got 1, 2, 3. All these three phases are rather standard. We just have to understand exactly what they mean, and if there are any alternatives that we should really understand, right? So these three are rather standard. And this number 4, phase number 4 here, is really up to your need for the application. But there's certain part that's kind of a need that we will also need to discuss. Especially, this is something called typecasting, and we're going to talk about it today as well. But let's talk about the previous phases first. So we're going to go phase by phase, and after each phase, we'll also do some example. All right, phase number 1. So the big picture is, now the point V2, by default, is going to be a child class of the object class, meaning that this default version is going to be inherited to this point V2. But since we got some explicit overriding of the equals method, so this default version is no longer applicable, right? So that's kind of the reasoning. All right, let's talk about this here. Line number 1. Line number 1 goes like this. So if you kind of recall from call by value very quickly, okay? So let's say we got our object over here. Let's say if I say P1 dot equals and P2, all right? And call by, so this is the context object, and this is the argument. Let's say the argument P2 is actually pointing to this particular object, let's say some objects. And then call by value tells you that obj, the parameter, is actually going to point to the same objects, right? Call by value. So this is the parameter, and this one here is the arguments, right? Nice and clean. And then line number 1 of the equals method says like this. We say that if this, what's this? This is the context object, right? So think about context object this. So that means P1 may be pointing to some other objects right here, all right? And then we're saying that this is just pointing to conceptually the same object. So this is the context objects, sorry. Right here, all right? And what this line is saying is, if this and obj, if they happen to be pointing to, you can see the equals right here, right? It's comparing the address. If this and obj, if they happen to be pointing to the same objects, they should be equal to each other. So just return true, unconditionally. So this is saying, if you are doing P1 that equals P2, and P1 and P2 happen to be just the same pointers, pointing to the same objects, in that case, equality should be true by default, because anything should be equal to itself. All right? It's a very important principle. Sounds simple, but important, right? So this one here is saying that anything is equal to itself. Right, that's this line here. Any questions? Just about the definition. And let's now do some code tracing right away, just to emphasize. Okay, example code. Okay, let's now just consider line number 7 right here. Okay, and let's now just revisit our decision making. The context object is P1, right? And P1 over here is pointing to some point V2 objects, right? So we know that this is the dynamic type of P1. Telling us we should really go to the point V2 version. So overridden version is invoke, right? The overridden version, which will be right here. All right, right here. Okay, oh, sorry. So this is the overridden version that's going to be invoke, which is good. All right. And then let's do the call by value kind of reasoning. Obj is going to point to wherever P1 is pointing to, right? Arguments. So obj is also pointing to right here. And what about this? This is the context objects. So this is the context object. So this also happen to be just P1. And then when we trace this particular code, we say this equals obj. We are comparing this and obj. They are the same objects. So return true. Simply because we're comparing P1 to itself. I'm just doing a tracing again. All right, any questions about this? Okay. So this is going to be just executed. All right, this is just going to be, so this will be just return true because P1 and P1 are the same objects. So what we have done so far is to look at the very first line of the overridden version. That one there is saying, whenever you're trying to see something that equals something else, if those two things happen to be the same objects, return true automatically, unconditionally. In this case, this over here is referring to the context objects. Obj, the parameter here, is going to be a copy of the arguments. If they just happen to be the same objects, of course, they are the same. All right? And this case here is even more explicit because P1 and P1, the same variable. But sometimes, if you actually got, for example, let me give you another example here. I'll put it here. Okay. So think about if I say P1 dot equals, let's say P4. Okay. Let's say there are different references. However, if at this particular point of execution, if it happens that, let's say we have some point V2 objects here. Okay, I'll say point V2. And then the context object P1 and also the argument P4, they happen to be aliases of the same objects. In that case, you will still get true, trivially, because this and obj, they will point to the same objects, right? So this one here will also return true. Return true as well. So the first line here is pretty simple and straightforward. Any question about the first line? All right, let's now move on to the second line. The second line here, so we already passed the second line. Here is a little bit of important question for us to think about, right? The way we execute the code is going to be line after another line. If this Boolean condition is true, we would have returned true. If we are able to get to phase number 2, what does that mean? That means we didn't really return true because this condition here is false. All right, it's a very important logical reasoning here, right? I'm going to write it down, okay? So we want to say that if we are able to reach this line, reaching this line means that this condition here was not satisfied. This is not equal to obj. That simply, we know that if this and obj are the same objects, we return true right away. If they are not the same objects, maybe different locations in the memory, they might still be equal to some extent, but we just gotta use other phases to determine. We cannot use phase number 1 to say that we return true right away, right? So that's the logic here. So if you're able to reach that line, that means this and obj, they are different objects, right? I'm gonna write it down. Okay, so let's now visualize what we know so far. So that means this and also obj, right? Obj is a copy of the arguments, right? This and obj, they are simply pointing to different location in the memory. Or maybe they're simply not, just somehow that they are not equal to each other, address-wise. Okay, that's the starting point for phase number 2. And then we say that the following, okay? We say that if obj equals null, and we return false unconditionally. So phase number 1 and 2 are kind of interesting. Phase number 1 gives you a condition where you can just return true unconditionally, well, automatically. And phase number 2 gives you another condition that you can simply return false without any further comparison, right? So let's understand phase number 2. What does that really mean? To really understand that, I would suggest we consider an alternative version of phase number 2, okay? So let me just put it here. So phase number 2 is right here. Okay, I'll make it a little bit bigger. Okay, right here. Okay, phase number 2. And then I'm just going to consider some alternative. Alternative right here. So we're saying that if obj equals null. Before we say that return false, right away. But we never asked about what's the value for this, right? Why don't we try to say something about this? This can either be null or not equal to null. Agree? Okay. So let's now do that condition there. We can say if this equals null, and then we do something here. Otherwise, we do something else. Okay? Look at this alternative version very carefully. So somehow logically, it's maybe a little bit easier for you to follow to see the thorough case analysis. Okay? Let's see what we're doing here. Given that obj equals null, which corresponds to this condition here. Now I'm further dividing into two cases about this. If this equals null, that means we're comparing null and null. Null equals null is true, right? In that way, I can say return true. On the other hand, if I get to the else part, what does that mean? That means this is not equal to null. I can also write it down. So else means this is not equal to null. In this case, I'm comparing null and also not null. Something that's null versus something that's not equal to null should be false, right? So that one there is going to be return false. Okay, let's pause right here and then consider this a little bit more verbose version right here. All right? So we're basically doing two conditions here. Okay, let me just highlight it and then we'll talk about it. First of all, we do obj equals null, and we also compare if this equals null. If null compare with null, true. If null compare with not null, false. Kind of clear about this logic here? All right. And now here's the question is, why do we not include the alternative version that's longer there as a standard? Why was that? Why do we simply disregard? Somehow the standard version simply say, you can return false right away without worrying about what this is. You don't have to check to see if this is null or not. Somehow the standard version disregard this check and simply just return false directly. So here is something we got to understand. Anyone? Daniel?
You mentioned this can be null.
Yeah, what if, yeah, so somehow the this equals null is something we can see in the alternative version there, but it's not included in the standard version. Why is that?
Maybe because if we can invoke the equals method, then it means that this has been instantiated.
That's very good insight. You're saying that if we are able to call the equals method on some context object, which is this, that means we should be able to get this, right? You're missing something here. We'll put it in this way. What if this is really equal to null? What will we get? Can we even get to this point of execution? Anyone? It's a very deep thinking here, right? We are really trying to understand exactly why. I don't want you guys to just memorize the two lines, right? You got to understand what's going on. Go ahead. Yeah, when would you get a null pointer exception? When the method is called. So you don't really even get to the phrase number one, for example, right? All right, good. All right. So let's now make it more concrete. Let's say, for example, when I consider some method call, let's say obj is not equal to null, right? Let's say it is not equal to null. And then when I make a method call to say, let's say p1 dot equals p2. Let's now consider, let's say p2, which is going to be copied to the obj, right? The argument copied to parameter. Let's say this is not equal to null. And p1 over here, if p1 equals null, which is the condition we thought we should check in the verbose version. If p1 equals null, are we even able to step into this method here? That's the question. We shouldn't be able to, right? Because if p1 is already null, you have no context object to invoke the method on. It's something even will happen even earlier, which is null pointer exception. All right? So this one tells you that you will get null pointer exception, right? Just a short form, null pointer exception, even before we step into the body of equals method. Okay, it's a very important thing to understand, right? Whenever you talk about any method call, the context object should be not null. If it is null, you just don't even have a chance to really step into the body of the method. So this is to say, right here, the final conclusion. This part here might help us understand kind of the logic so we can see the complete, like a thorough case analysis. But this code here is, we say, logically not reachable. All right? This is not even reachable. Not reachable because null pointer exception would have occurred already. You don't even get a chance to check it, right? Would have occurred. All right, let me highlight it. All right, any question about phase number 2? The first two phases are rather simple. You can see either return true or return false, but logically you ought to know why we should return true in one case and return false in the other case. All right. All right, let's now move on. Now, let's get to the most confusing part, right? Phase number 3 and 4. But of course, to really get to phase number 4, you want to also understand phase number 3. And to really understand phase number 3, we have to cover some new terms, which you kind of promised earlier. Okay? And, before that, why don't we do just one example, and then we'll go to phase number 3. Okay? Just one example. Let's now consider this line here, right? Line number 8. Okay? P1 over here, context objects, which has the dynamic type point v2, right? Point v2, which has 2 and 3. So that means we're going to invoke the version of the dynamic type, right? So this is the dynamic type right here, all right? And let's now try to visualize a little bit. So now over here is the argument value. And we know that obj over here is the parameter. So obj is going to copy whatever that's in argument, which will be just null, right? Pointing to not nowhere. And then we got P1 over here, which will be this. You can think about context object is this, right? So we got everything set up over here. So let's now step into the execution one by one. First one, this equals obj. This equals obj, false. Something that's not null is not equal to something that's null. So this will be false, which means we don't really execute return true. So we get to the second phase. When you get to the second phase over here, obj equals null. Obj over here equals null. Indeed, it is true. In that case, we got to return false because P1 is not null, but it's compared to null. Of course, it's going to be false. So P1 is actually not equal to null. Otherwise, we would have got null pointer exception. And the null value we are passing over here is not equal to something that's not null. So that's why it's going to return false. Okay? So that's why this line here is going to give to you false. So this method call over here is going to give you false. That's a result. Okay? All right, any question about phase 2? Okay. And we're going to move on to phase number 3. Okay, so phase number 3, let me just tell you, we're gonna do some background study quickly. Okay, but not quickly, thoroughly. So phase number 3, which will be here, we are going to call something called get class. I'll explain exactly what that means in a moment. And also we're going to do something called typecasting. Okay, so these are the two things. I'm going to do. All right, let's do this page here. Right, this page here is something that we'll also elaborate even deeper when we talk about inheritance, but for now, it's more like I just get some intuition and learn some terms in a more intuitive sense. Right, let's go one by one. Let's now start with something called static type. So there are two notions of types in Java, right? Now we should really distinguish between them. One is called static type. The other one is called dynamic type. Okay, these are the two. What's really static type? Static type is the declare type. For example, you can see O1 and O2. They are declared to be different types. So the static type for O1 is C1. The static type for O2 is C2. Okay? Why don't we make some little table here just to illustrate very quickly. Okay? So if you think about different variables over here, okay? Let me just choose some. So these, the variable and also static type. So you got O1 and O2. You also got O3, right? O1, O2, and O3. They are declared simply of different types, right? That's how you judge. Just look at the declare type. O1 static type C1. O2 static type C2. O3 static type objects, which is the default class we talked about earlier. It's also possible to declare static type to be objects. Okay? And then let's now talk about what's so useful about static type. First of all, one most important thing you got to remember, the declare type of static type, once it is declared for the variable, you can never change it. Never, ever. It's always fixed. And once you declare a reference type to be certain type, it determines about the range of methods you can invoke on that particular reference variable. I'll write it down first and I'll explain. Okay? The declare type determines the range of methods that can be invoked on a reference variable. Okay? So the keyword over here is about the range of methods that can be invoked. Static type. Okay? For example, when I declare, let's say C1, O1, and C2, O2, okay? Think about the range of methods that can be invoked on O1 and O2. O1 over here, static type is C1. If I look at C1, definition here tells me that it has M1. So I can definitely call M1 for sure. All right? So here you can think about, which is something I call expectation. What kind of method can we call right here? So expectation. Okay? For O1 over here, the declare type is C1. And C1 has the method M1 declare. So of course we can call M1. On the other hand, you can see for O2, declare type C2. And that one there has the method M2, right? So you can see O1 and O2, they have different expectation because they got different declare types. Okay? What about objects? For object, you got to think about what methods are declared over there. Equals for sure, and toString, right? Things like that. Okay? Okay, and then we got, so for example, equals. Let me just put equals for now. Okay, that's what we care, equals. Okay, to complete the story, let me say a little bit more about expectation very quickly, okay, to get intuition. We say that object is always the parent class for every class. Object has, for example, equals method right here, toString hash code as well. Okay, so here we got two subclasses. Let's say we got C1 and C2, right? You can see the C1 and C2 right here. C1 and C2. And we see that C1 declare M1, C2 declare M2. So I can put M1 here and also M2 over here, right? That's just from the explicit declaration. One missing bit. Remember we said also earlier, the equals method will also be inherited to each method as well, right? So that's the missing bit. So anything that's from your parents will also be inherited. So in this case, we just have to worry about object class, right, at this point. We'll see a little bit more in general sense when we talk about inheritance. So this will also be inherited to here. So that means equals method is also fine to be callable. And here, equals method can also be called as well, inherited, okay? Okay, let's go back here. So in the table. So that means for O1 and O2, what expectation do you have? Not just about N1 and M2 that we spoke about, but also you got the equals method, right? You can also call equals method here. You can also call equals method here as well. But just notice that you cannot call M2 on O1. You also cannot call M1 on O2 because it's not declared over there. All right, expectation. All right, static type, all you need to know is it's fixed, cannot be changed. And also, once you have the static type, you can determine about the range of method that can be called on that particular variable. The only way you can somehow seemingly modify the expectation of a variable once it's declared is somehow do a cast. But cast is not really modifying the original expectation, but we'll talk about it, okay? But for now, that's static type. Any question about static type? All right, question?
If C1 and C2 had a modified equals method and you were to declare them as objects and then you called that equals method, would that invoke the method?
Good. Yeah, so here what you're asking about is like a which version of the equals method will be called. That's a different dimension. So here we talk about static type, which only tells us about what method you can call, first of all. It's more like a compilation issue, right? Where you can call a method on the objects. On the other hand, which version should be called is about dynamic type, which you will see, right? Yeah, exactly. So so as long as you can call the method, and then at the runtime, you get to determine what's the dynamic type for that context objects. Yeah, we'll see that, okay? It's a good question, but we'll explain that using an example, okay? All right, dynamic type. Dynamic type is something we said earlier, but let's now just revisit very quickly. Dynamic type is really the type that's gonna changeable at a runtime, may be changed. As opposed to fixed. And we also call that runtime type if you wish. And dynamic type determines about which version of the method that's going to be called. So whenever you're trying to trace your code and want to determine which version of the equals method to be called, you got to look at dynamic type, right? Just the principle we said last time. Determines the version of method being called. All right, static and dynamic. This is something we are still going to use a lot once we get to the inheritance later, right? So just get some intuition. That's your first exposure to these two at the same time. Typecasting. Typecasting here, I'll just read the definition together with you, and then I will visualize it when we get there in the tracing. Typecasting, okay? You're basically creating an expression, or you're creating some alias. Think about whenever you're doing typecasting, you're not creating a new object. All you're doing is you're creating like a copy of the address, but with a different expectation. Okay, I'll write it down. You're basically trying to create a new copy of address with a different expectation. It may not make much sense at this point, that's okay. I'm going to visualize it, you'll see exactly what I meant. So just remember, whenever you do typecasting, a very common misconception is, are we creating a new object? No. Are we modifying the original static type for the reference variable we're trying to cast? Also no. We're creating a new variable with a different expectation. Okay? But we'll see. Let's now try to trace this code right here. And then we'll find out the pattern. Okay? As far as the equals method is concerned, understanding this fragment of code should be enough for us to at least study about phase number 3 and 4. Okay, let's take a look. Okay. Before we dive into it, how about we just take a short break, halfway. Okay. All right, so before the break, we spoke about static type, dynamic type, and also a little bit about typecasting. Let's see exactly how we can apply all these concepts over here in the code, right? Let's go one by one, line by line. Any point you start getting confused, interrupt me, okay? It's okay. But this page here, I'm telling you, is very important, okay? Okay, let's now trace the code very quickly, okay? So first of all, let's now trace these 2 lines right here, okay? These 2 lines. I'm gonna visualize like this. So I got O1 pointing to an object right here, and then of certain type, right? I'm going to leave that empty just for now, okay? And also I got O2, okay? And that one there also got another object over here, okay? So now, I would suggest when to really make sure you understand completely the difference between the 2 types, let's do the following. When you're doing this, let's see what a static type is. Static type is going to be C1 versus C2. You can simply put C1 here and C2 over here, static type, what they are declared to be. And dynamic type is going to be on the name of the constructor. So here, C1 should be here and C2 over here. They happen to be the same, I agree. But don't worry, you will see many cases where they are different once we talk about inheritance. For now, just simpler when they are the same. But just let's still distinguish between them, static type, dynamic type. So these are dynamic type. All right, let's now think about just method call. Whenever you're tracing, right, if I didn't even tell you if the code compiles, you should really worry about compilation first, right? Let's now look at these 4 method call. These 4. O1, O1 versus O2, O2. M1, M2, M1, M2, right? I'm just giving you all the combinations. Now, tell me which lines are not going to compile. And one important principle here, I'm going to write it down as well. Whenever you want to decide whether a method call should compile, think about static type only. You don't worry about dynamic type until you want to determine the version of the method being called. All right? Give me one line that's not going to compile. O1.m2? Okay, I agree. Okay, guys, let's take a look why. O1 over here, if you look at that, that one has the static type C1. And C1 has M1 declared, but not M2. So it's not part of the range. It's not part of the expectation. All right? So this one here is not going to compile because N2 is not part of O1 static type expectation. It's like a very complete description. And similarly, how about this one here? O2.M1. Would it compile? No. Not for the same reason, right? Because if you look at that, so here, let's do the same reasoning. O2 over here has the static type C2. Static type C2. C2 only has M2. It does not have M1. Also, does not compile for the same reason. Okay, you can write it down. Okay. So the only 2 lines that will compile are these 2. Only these 2 right here. Okay, you can invoke. Okay. Any question? You can think about these 4 lines are more like a practice about how you can use the static type or declared type to determine if a method call will even compile. once it compiles, at the runtime, you're going to look at dynamic type. Let me write down this principle here. This principle, again, is going to be used throughout the rest of the course. Okay? Given, typically, okay, how about this? Given a line of method call. Let's say we got obj, some objects dot some method. Okay? So now there are two typical questions. Question 1. Does the line compile? And question number 2. If it compiles, which version of M is called? You can think about the M here, maybe just the equals method, right? So right now, for all the other methods other than equals, you only got one version, which is declared in your class. But that's okay. I'm just talking about a general principle. Once we talk about inheritance, for any method, there might be multiple versions that exist, which we'll have to deal with. All right? So question number 1. Does the line compile? You have to look at the static type of context objects, obj. Look at the range of methods that you can call. If M is one of them, compiles. And question number 2. If it compiles, which version? You have to look at the dynamic type of the context objects obj. For example, if method M happens to be the equals method, if the dynamic type for obj is .v1, in that case, call the default version. If the dynamic type for obj happens to be .v2, then call the overridden version, right? It really depends. So both questions are very, very typical. One is about compilation. The other one is about runtime behavior. Both are important. Okay, we'll revisit many times. Okay, let's now move on. This line here, next line, is interesting. Okay, we now declare O3 to be of type objects. Object in some way is the class with just the equals method that you can call, right? As far as we are concerned. Okay, so think about what's happening here is we're having this. So let me move this one here a little bit downwards, right here. Okay, I'm going to put obj, so objects O3. O3 is simply a reference variable. It's going to point to somewhere. At this point, it's not pointing to anywhere at this point. And then the static type is objects. Okay, and one, if you like, one little rule just for us for now. We need to we wouldn't need to know why, but you can take some explanation. Okay, whenever you have anything like this, if you declare objects and then some obj, and then you want to say either it is some new let's say some class. Okay, or if you say objects obj equals maybe another variable obj2. Right? So these are the two typical lines you can write, right? Either you can say obj is assigned to some new objects, or obj is copying the address of obj2, right? Either way. Now here's a rule. Given how special object is, we know that object is the parents of every class. So here's the rule. The sum class over here can be any class. That means when this and this are different names, if this one happens to be objects, this can be anything. It's more like a special rule we should know for now. But we're going to see how this can be generalized a little bit later. But for now, just remember, if you got declared type to be objects, the right-hand side can be anything, which we'll see. All right? And also, if you try object here, obj, the obj2. obj2 is declared to be certain type. The declare type can also be any class. So these two variable assignments always compile. Just given how special object is. So that's something you will see. You can take it for granted just for now. Okay? We're going to explain exactly how there are certain rules you have to follow about variable assignment, but not for now. Okay? Just remember the special case. All right, let's now move back. All right? Now, I want us to consider two things over here. Look at line here versus the line here. O3 and O1, and also O3 and O2, right? Which are reassigning that, right? O3 was declared to be objects. O1 was declared to be C1. But according to our rule, that's okay. All right? Similarly, O3 equals O2. O3 declared to be objects. O2 declared to be C2. Also, according to our rule, that's also fine. All right? So let's now see how we can do tracing. Okay? Let's say after this one here. Let's say, let me use orange. How about purple? Let's say after this. Okay? Let me just put a star here. After the star, O3 is going to point to wherever O1 is pointing to. Okay? So that's the star. Now, we're going to make some method call. O3 is actually pointing to C1. And we know that C1 has M1 declared. Right? So now, can I actually say O3.M1? Okay, for those of you who say yes, I successfully misled you. Let me say it again. I'm misleading you again. Okay, it's very important, right? I'm saying the following. After executing this line, I know that O3 is pointing to dynamically a C1 objects. I know that C1 has M1 declared. So it makes sense that I can call M1 on O3 so that this line is going to compile. If you think yes, you got to adjust your mindset, right? Remember the principle we said. When you want to determine whether a line should compile, what should we look at? Static type. And the way I misled you, I only talk about dynamic type, right? So it is very important for you to know both of these lines do not compile. These two lines do not compile. For a very simple reason. O3 was declared to be of type objects, never changes. So that means whenever you want to use O3 to really call some method, it doesn't really matter what O3 is pointing to. Doesn't matter. It only matters about how O3 was declared to be, in which case it's objects. Does object class has M1 or M2? No, it doesn't. So that's why these two lines do not compile, okay? Because the static type of O3 remains to be objects. The object class does not have M1 and M2, right? Very important, okay? Now, how can we make it work? Because I somehow really want to call the N1 method on C1. I cannot really use O3 directly. However, typecasting allows me to create an alias to the same objects. When I create an alias there, I can specify what should be the static type for that alias. I'm not really modifying the static type of O3. I can never do that. I can only create a new alias and make that alias has maybe C1 as a static type. That's what I can do. And once I got an alias with the expectation C1, I can then call M1. All right? So that's what exactly you will see right here. Okay, let's now take a look at here. I'll make it bigger. This one here. This is something called typecast. Okay, I'll highlight it right here. So just look at just this one here. I'll make it a little bit smaller. So here, how do we read it? Okay, I'll put it here as a notes. So if you think about O3 and then C1 over here, this is so-called, so we are really casting O3 to C1. However, casting O3 to C1 sounds a little bit misleading. It sounds like we are changing O3. We're not really changing O3. Okay, so I would suggest maybe this is the way to understand. Okay, I'll get rid of this. Okay, the way to understand will be we are basically this refers to a new alias. That two things. Number one, points to the same object as O3 does. So since we are trying to do cast O3, so point to the same objects. So what we're doing is we're creating an alias right here, pointing to the same objects. At the same time, we can say about what's going to be the new expectation for this particular new alias. This new alias has the static type same as the cast type. So C1 over here is a cast type. And we're saying that once we have created this alias over here, that one there has the static type C1. All right? Or I can just put a little bit more like this. You can think about C1 cast to O3. All right. So now if we do this method call here, this expression, I'll write it down, maybe stay away. Thinking this way. So when I got C1 O3 dot M1. Let's again understand from a different angle. O3 itself is pointing to some objects over here. That one there, we know that at the moment, it's actually C1, right? And then O3 over here has the static type C1. Okay, that's what we have, the green one. When we do typecasting over here, we are basically creating an alias over here that is simply O3 and C1. So think about this alias over here. This alias has the static type C1 corresponding to the cast type. And then I want to invoke a method on this particular alias. Now I will be able to call M1 because the alias has a static type C1. So that means I can call that. All right? So here, this alias, this expression here has the static type C1, meaning that we can invoke methods from C1 on it. Just notice that, so when you say C1 and then O3 and then .M1, right? So you can see that we actually got parentheses right here. If you didn't really have the parentheses, if you simply have that, it's not going to work. The way Java is going to think about it is it's going to somehow do the method call first and then do cast. That's not the order we want. We want to do typecast first, create an alias, and then invoke the method. All right? So this one here is not a way to go. Okay? So this one, the parenthesis tells us that typecast first. And then call M1. Right? Any question about the typecasting? We'll still get to still revisit that, but for now, you just gotta remember we are really trying to create an alias. And because the alias has the right static type for us to invoke M1. So that's why it's gonna work. Question?
Is this like testing just temporary? Like once we use it, will it just return to the object?
What do you mean temporary? In what sense?
So like if I did like this typecasting M1 and then I do O3.M1, will it use the object instead of?
So if you're simply using this, so that means the context object for the M1 is actually this alias, which is which has the static type C1. So you can invoke M1. However, after this line, if you still say O3.M1, it still doesn't compile because O3 itself always has a static type objects. Okay, I just made some typo there. Okay, I'll just fix that. O3, according to our definition, actually just got objects, right? Maybe for later. Okay, think about it. Okay, good. All right. All right, so this line here is actually going to be good. How about this line here? All right, let's look at this line here. Okay, method call. I'm still trying to create an alias, right here, C103, C103. And this context object here has a static type C1. Can I call M2 on something that's C1? I cannot. All right? So this line here is not going to compile. Okay? So whenever you're doing typecasting, make sure you call the right method on the cast. This cast over here has a static type C1. So we can only call M1 but not M2. All right? Because the cast type is C1. All right, similarly, exercise, think about for these two lines. So here, I'm basically creating another alias over here. Because after, let me show to you. Let's say for this particular line, star star, O3 is now going to point to right here. Right? After that execution. And then I now actually want to invoke M2 on this particular object here. But if I directly use O3.M2, I cannot do it because static type restrict that. So what I should do typecasting. So if I do O3C2, right? So that one there, if I got O3C2, I'm basically creating a new alias pointing to the same place as O3. Right? O3 is currently pointing to this object here. So that means I got C2 and then O3. So the static type for this cast over here is C2, right here. So I can call M2, but I cannot call M1. All right. So I can call M2, but I cannot call M1. Cannot do that. Okay. There's quite much information here in this single example. We really try to demonstrate about static type, dynamic type, and also typecasting, right? Any part you want me to revisit? Yeah, go ahead.
If we just invoke M1 or M2 on O3 without casting, what's the use of O3 O2?
Daniel, sorry, say it again.
If we can't call M1 or M2 on O3, what would that line O3 equals O2 be used for?
So, well, it depends on what you need, right? So basically, we're just demonstrating to you about, when you write a Java code, what you might encounter. So what we're saying is, when you declare O3 to be of certain type objects, this allows you to really reassign O3 to any other object at the runtime. So the fact that it's declared to be object, you can reassign it to anything. Object is very flexible. Object, think about O3 can store the address of anything. So that's why at the runtime, you may be pointing to some C1 object dynamically. We might be pointing to C2 object dynamically. When you want to call a method that's very specific to the dynamic type. Let's say for C2. But you cannot call O3.M2 directly. You have to do a typecast before you can do it. So that's why. So let me also delay the discussion a little bit. Once we talk about inheritance, we also need that as well. Okay. By this point, just remember object is a very special class where it might be a static type, in which case on the right-hand side, you may reassign the object to anything. Okay. All right, think about this, and then I can do some quick recap, maybe again on Wednesday. Okay. Let's now move on to phase number 3 and 4, right? So now this is the most important background for us to understand about the static type, dynamic type, and typecasting. Let's now do discussion here. Phase number 3. Okay. If we are able to get to this line, so that means this condition here is false. And also, this condition here is also false. So this is false, and this is false. What does that mean? That means we know that this and objects, OBJ, parameter, they are not the same objects, not different addresses. And also we got OBJ also not equal to null, right? We know these two conditions. Now for phase number 3, what are we doing here? Basically, this .get class, I'll visualize it. So the get class and also get class. So these two are calling this method called get class. That's actually going to get the dynamic type of the context objects. This is going to return the dynamic type of the context objects. The idea is when you try to compare like objects, right? We don't really want to compare apple to banana. We don't want to compare apple to apple. For example, you don't want to compare point V1 with string. You don't want to compare vaccine with distribution center, right? You want to compare really objects of comparable runtime type. Okay, that's what we're doing here. But let's now visualize a little bit, and then we'll do example. Okay. So this one is saying if their dynamic type are not the same, you can see the not equal here, right? They are not equal, return false. Okay. Conceptually, think about if the dynamic types of the two objects are not the same, they are not equal to each other. Objects with different dynamic types are trivially, which means we don't even need to bother to compare their contents, right? Trivially, not equal to each other. Okay, let's now visualize this a little bit. Okay, so let's say if I got maybe context object this, it is pointing to some object over here, and also since we know they are different objects, maybe I got OBJ. They are different objects right here. Yeah. And so I got OBJ, which is not equal to null. I also know that, right? So OBJ is actually another object here, and now get class. When I say this .get class is going to return back to me the title of the box, dynamic type. So think about this one here. It could be some triangle, for example, symbolically, right? So think about this is this dot get class versus maybe this one here, just another maybe class. Maybe it's a star, okay? And this one here is OBJ dot get class right here, right? OBJ dot get class. So we're getting the two dynamic types. If these two are different, no way they are the same. All right. Let's now see example, okay, which we saw earlier. Let's see them again. from a different angle. So let's now consider this line here. So we got line number 9 right here. All right. So we got P1 dot equals S. Okay. So P1 over here is a context object. You can think about this is also pointing to P1, right? Context objects. And also you got S over here, which is a string. And you can see that right here. Okay, I'll visualize it right here. So S is pointing to some string objects right here. And call by value tells us obj is going to point to the same as the arguments. All right. Let's now check very quickly. This equals obj. This equals obj, not the same objects. Right? So, bypass. So this one here is going to be false. So we don't execute this branch. And then we get to the next one. Obj equals null. Obj is pointing to some string objects. So also it's false. So we don't execute this branch. And then we are going to actually do this one here. This .get class is going to give us point v2. And then obj.get class is going to give us this one here. Okay? Are they the same classes? Not the same, right? So that means they are not the same classes. Not the same classes. So point v2 is not equal to string. So this will be simply true. They are not the same. So we got to return false. Okay? So that means this particular line here is going to return false. Because P1 and S have different dynamic types. All right? Question? Okay, think about it, guys. Yeah, I think it's quite a bit of stuff today, but I think let's just go through, a little bit more, and then you can also take some time. Of course, in addition to studying your written test 1, think about this kind of issue, right? It's going to impact quite a bit, for the inheritance lecture later as well. All right, let's now talk about the final phase. I think we can do something right now. Okay, final phase. For the final phase, we basically, if we are able to reach this line right here, final phase, that means all the previous Boolean condition evaluate to false. This is false, and also this is false. Let's write down exactly what they really mean. That means number 1, this and obj are different objects, not the same objects. It should be false. Number 2, obj cannot be null. Otherwise, we would have returned false. Also, obj not equal to null. Guys, what about number 3? What should I put here? If I'm able to reach that line for typecasting, what can I say about the dynamic types for this and obj? They are the same, exactly. Logical negation, right, for that. Awesome. So here, number 3, okay, I'm running out of space, I'll put it here. Obj dot, this dot get class. Let me write it out. This dot get class equals obj dot get class. More specifically, this is really referring to point v2, right? So that means this dot get class, I can infer that this one here is point v2. And given that obj dot get class is equal to it, I know that obj dot get class should also be point v2, right? That's the reasoning. Now, Let's visualize what's happening here. What we have is this. Let me start with this. Let's say this context objects is pointing to something dynamically point v2. And also obj, the parameter, different objects, and that one there dynamically is also point v2. And we talk about how to reason about this. Right? This and obj. Different objects, but we are comparing banana with banana, right? The same dynamic types. And now, we want to somehow compare these two by their contents. I know that, presumably, there should be x and y, some value here. There should be also x and y right here. Let's not worry about what's defined in the yellow highlight. Can I write the following? I want to compare basically this with this, and this with this, right? X with x, y with y. Can I simply write this dot x equals obj dot x, and this dot y equals obj dot y? Can we write this? Okay, give me 1 minute. What's your thought? Can we write this? It would be nice because if this will work, then the standard version is more complicated than it needs to be. That's a very important conclusion for us to make. Anybody? Go ahead.
I don't think it's going to work because OBJ is object type, so it's not like say static type, so you have to do type casting.
Exactly right. All right, guys, this will be a nice way. Give me 1 minute. I'll draw a closure on this, and then we'll continue. Right? Give me 1 minute, please. First of all, let's look at the declaration of OBJ. We declare OBJ. OBJ has the static type objects. That means OBJ over here and OBJ here, we can only invoke something that's declared in object class. Is x and y declared in object class? No. They will only declare in point v2. So these two parts are not going to compile. This one here and this one here. Okay, let me write it down, and then with these two not compiler. Because OBJ's static type does not support x and y. Final question. What should we do in order to make sure OBJ is really pointing to some point v2 object as we visualized? How can I make sure I can call x and y? What should I do? Typecasting, exactly, right? So guys, we'll continue from typecasting on Wednesday. All right, so please review. Also, good luck to your written test 1 preparation. I'm still in my office hour, okay? Take care.